Hello, beautiful geometry students. Welcome to lesson 2.04, where we're going to continue our work with triangle congruence. So go ahead and check out the do now. Use the abbreviations of A and S to show the notations marked on the diagrams. Don't forget, A stands for what? Angle, and S stands for side. So if there's a tick mark on the sides, put an S. If there's an arc, put an A. Pause this video to check your work on the do now. You're going to do A and B. All right, so the first one is side, side, angle. Don't forget, you can't skip to the other side or angle if there's nothing there. So we're going to go side, side, angle. Number 5 is side, side, side. And number 6 is angle, angle, side. So here's a little smart tip. If there's a double S like 4 or double angle like 6, start with that letter. Part B. Which triangle congruence theorem can you use to prove triangle congruence below? So I have side, angle, side, side, angle, side. So I'm missing my segment notation. You need a segment on top of AB, DE, BC, and EF, so please add that. So AB has one tick mark, so that's congruent to DE. So we're going to build on corresponding sides and angles. The congruent angle here is B and E, and don't forget, we only use one letter if the triangles are separated, but you know what? I'm going to switch this up to A, B, C, and D, E, F, because we are going to most likely use 3 letters for the regions and summatives. And our final side is going to be BC with the 2 tick marks and EF with the 2 tick marks. And because it follows SAS, that triangle congruence shortcut, it means the whole triangle ABC is congruent to DEF. Order matters by side, angle, side. Don't forget, we have a new triangle notation, a literal triangle in front of DEF. All right, so pause this video if you need more time. And let's move on. Review. Which theorems prove triangle congruence? So we learned ASA, SAS, and SSS yesterday. And we're going to add on AAS today. So let's look at AAA though. If 2 triangles have all 3 congruent angles, check it out. 40 degrees, 40 degrees, 105, 105 degrees, 35, 35 degrees. Does this prove that these 2 triangles are congruent? That they're the same size, same shape? No, they are not the same size, same shape. So AAA is out. Outie. Now, here's another trick, super important for the regions. If your triangle congruence, and this doesn't count against Ms. Cho cussing because I want to make it sticky so you remember, if your triangle congruence spells ass in any way, forward and backwards, that's not a triangle congruence. So remember, if it spells AAS or SSA, something is off. It is S. So moving on. These are our 4 triangle congruent shortcuts. So today, I can apply properties of vertical angles and reflexive property to prove triangle congruences. Example 1. Flip the page. Given AB is congruent to DE, and you can annotate on your paper as I read. Given that AB is congruent to DE, angle A is congruent to angle D, and angle B is congruent to angle E, prove that triangle ABC is congruent to DEF. So, step 1, label or annotate the triangles with the information given. Remember, we always start with annotations. So AB is congruent to DE, A and D are congruent, angles A and D are congruent, and B and E. Step 2, determine the triangle congruence shortcut based on the annotations, the labels. So triangle congruence shortcut just means 3 letters. And here it is ASA. It's an angle side angle sandwich. The side is in between the angles. So now we're getting into the proofs. So remember, geometric proofs are like logical arguments. Just like the UNO's activities, you start with the given. Oops. I'm going to put the triangle congruence on the side. And this is like our compass, our roadmap to our proof. So the first, we're going to write A, and we're going to start with the angle. Angle A is congruent to angle D. There's more than one givens here, but we're just going to start with A, following the order. 2, sides. AB is congruent to DE. That's also a given. And angle B, is congruent to angle E. That's a given. Therefore, because triangle ABC is congruent to triangle DEF because the ASA theorem. Don't forget, if you have an A as your shortcut, you need an angle example in your statement. If you have an S, you need a side example. Yesterday's lesson, I saw people put an A for angle, but they put sides as the statement. So make sure they match up. Pause this video if you need more time. Now, try the check for understanding. So follow the steps on the page above, step 1, step 2. And please try on your own. If you just straight copy, you're not going to learn anything. And again, most likely you're not going to pass your summative. So help yourself. Put in the work in now so you don't have to put in the work later. When you're ready to check your work, play the video. All right, so given AB is congruent to DE, put a tick mark for the sides. BC is congruent to EF, and angle B is congruent to angle E. Prove that angle ABC is congruent to DEF. So step 1, I annotate. I see based on my annotations or labels that it is side angle side. And now I have to give the statements. Remember, the statements must have a congruent symbol. So the first side is AB is congruent to DE given. Next to A, we have an angle example from the given. And 3, we have BC congruent to EF. So all 3 reasons are given, and we always end with what we have to prove. That's super important. The whole point of this is to prove a mathematical argument. So we can say triangle ABC is congruent to DEF because of the side angle side theorem. Pause this video if you need more time. And we're going to move on to example 2. So here are the givens. CD is congruent to BC with the blue tick marks or the 2 tick marks. and AD is congruent to AB. Prove that triangle DCA is congruent to BCA. Now, not all annotations will be in the diagram, so we are going to have to make some inferences. We see that the orange triangle and the purple triangle share the same side, CA. This shared side is CA, AC is congruent to AC, or CA is congruent to CA, same thing. And this is a very special property. We need one more side, SSS, to prove triangle congruence. And this is called the reflexive property. To show that it's a shared side, you put an X instead of 3 tick marks. Think of reflection. It sounds like reflexive. When a side or an angle is congruent to itself. So, let's use the reflexive property in this next proof. So here we see that it is side, side, side. It has a shared side. So I'm going to use my compass, SSS, my triangle congruence on the side. So since these are all sides, my statement needs to have congruent sides. So the first 2 sides are given from the top. And we're going to add AC is congruent to AC. It's congruent to itself, so reflexive property. And we always end with what you're supposed to prove. So you copy the proof. Triangle DCA is congruent to BCA using the SSS theorem. Pause this video and press play once you're ready to move on. Example 3. Last one. So, given AC is congruent to DC, I'm missing my segments on top, my bad. And let's go ahead and annotate that. And BC is congruent to EC. Now, don't forget, sometimes we have to make inferences from the image. So what is the last side or angle for our triangle congruent shortcut? You could use 2.02 if you need a reference sheet or your purple sheet. We know that angle BCA is congruent to DCE because look, there's a perfect X, or there's 2 V's facing each other. So they're vertical angles, side, angle, side. So let's complete the proof. We labeled, we have our compass, side, angle, side, triangle congruence shortcut, and now we just need examples. I put in the givens. AC is congruent to DC, BC is congruent to EC. And for my angle example, angle BCA is congruent to DCA because vertical angles are congruent to each other. And we finally end with what we have to prove, and because of side, angle, side. So to summarize, label the diagram. Step 2, determine the triangle shortcut and put it on the side as your compass, your proof compass. You start with the givens and you end with what you have to prove. Start with the givens, end with what you have to prove, okay? So you can use this slide if you need a reminder. You're going to use both the reflexive and vertical angles properties and try the rest of the classwork. That's all I have for you. Don't forget, this will be collected, and be prepared to have one exemplar classwork to upload as a formative. Work the entire time during class. If you're absent, pick up a worksheet from school and watch a video at home, or you could print a worksheet at home, up to you. So trying to give you guys access to the curriculum as much as possible. So keep up the great work. Have a beautiful day all. Bye.